Hello, students. This is Mr. Bauer. I'm going to get ready to teach you lesson 2-1, but I also want to do some reteaching. I graded some of the tests. I'll get the rest of the tests finished today, but I noticed some areas that we were struggling in just a little bit, so I'm just going to do some reteaching. Um, and yeah, those of you that got a score lower than a 70, if you take notes in this reteaching and attach it to your note sheet that I gave you, the Google Sheet, then I will upgrade your score to a 70, okay? But you have to take full, like, a lot of notes, and like this whole thing kind of thing. Okay, let me go ahead and share my screen. Okay, test 1, reteaching. Combining like terms. I know I didn't talk very much about this in my lesson video. Of course, anything that is covered in the test is also covered in the textbook, so I do expect for students to at least try to go through all the examples in the textbook. But yeah, I know it's a very short time frame. I'll try to be a little more comprehensive in going over stuff. I think what I'll do is I'll have before the test, I'll make a video of like stuff that'll be on the test, kind of like a pre-test. All right, so combining like terms, I noticed several students messed up on those questions. Now I have 3xy plus 5xy equals 8xy. Let me explain. The basic rule of 3 plus 5 equals 8 stands here. Okay? Now xy represents two numbers that are being multiplied together. Okay? Since xy is the same in each of my three terms, then they are called like terms. When I say like terms, I mean that they are alike. They are the same things. We may not know what number x represents or what number y represents, but we know that both numbers are being multiplied together and being multiplied to 3 and to 5. Okay? So for our purposes, x and y simply just becomes a thing. So I have 3 things here plus 5 things is equal to 8 things. Because again, like I said, the initial rule is true. 3 plus 5 equals 8. Okay? So, like, the example I want to use is, we'll just say grapes. So I have 3 clusters of grapes plus 5 clusters of grapes equals 8 clusters of grapes. I guess I should make this look more like a cluster. Okay. Now, I know that sounds very preschool to say it that way, but the logic of it is basically the same. Okay. The idea is you have a specific group of things. I have 3 of those groups and 5 of those groups. 3 plus 5 equals 8, so 3 plus 5 groups equals 8 groups. Okay. I have a group of xy, a group of xy. 3 groups of xy and 5 groups of xy is equal to 8 groups of xy. Okay. Now, let's go into review on exponents. Notice some students did make mistakes with these. So with exponents, 3 to the power of 2, otherwise known as 3 squared, it means 3 times 3, not 3 plus 3. So therefore, your answer should be 9, because 3 times 3 is 9. Your answer, if any of you got 6 on a question like that, then that would be wrong. Okay? Now, let me say one of the reasons why this is a problem. I'll jump back to this problem here, but I want to say the mistakes to avoid. The first mistake is when people see exponents, they add instead of multiply. So for example, if they see 4 to the third power, they think 4 plus 4 plus 4. But it's not that, it is 4 times 4 times 4, which would be 64. Because 4 times 4 is 16, 16 times 4 is 64. Okay? The second mistake that people make is they multiply the base and the exponent. Okay? Let me just give an example of that. So 4 to the third power, some people might think that that means 4 times 3, which is equal to 12. Okay, now exponents are not just a fancy way of writing a regular multiplication problem. Okay, so I'm going to go ahead and circle that one and cross it out too. The only one of those that's correct is this one. Now, these two mistakes, there's a problem that causes these mistakes to happen. Okay, and that problem is the number 2 to the power of 2, or 2 squared. 2 squared, if I multiply the base and the exponent, 2 times the exponent 2, I get 4, which is the right answer even though I did it the wrong way. If I say that 2 to the power of 2 means 2 added 2 times, I get 4. Now here's the problem. When I multiply, this is supposed to be small like an exponent, I apologize. I did it the wrong way here and I got the right answer. Whoops, 2 plus 2. I'm making a mess here, apologize. I did it the wrong way here and I got the right answer. So the number 2 squared has a tendency to confuse people because you can do it both wrong ways and get the right answer. Okay, now that's just because of an anomaly that 2 happens to kind of like, well, it's because 2 is the only even number that also happens to be prime. Okay, simply it's that because it's small. So all even numbers kind of have 2 as sort of a root or a base to them. Okay, so, but having said that, 2 times 2 is equal to 4. It means 2 occurring 2 times, not 2 times the exponent 2. Okay? Talking about subsets, subsets are categories, okay? And just want to go over them again. Rational numbers are like fractions and decimals. Irrational numbers are usually square roots of non-square numbers or numbers like pi. Natural numbers are just counting from 1 up, not using any fractions. Integers are either positive or negative. In this case, I wrote -7. And whole numbers are like starting from 0 and counting up. Now, one of the things that's confusing is a number can fit into multiple categories. Like, for example, 4 is a natural number. It is also a rational number and an integer and a whole number at the same time. Okay? So the thing is, you want to try to make examples of the numbers that sort of like make you think of that number. Okay? Like 0 would be the best example of a whole number because that's the only, 0 is the only number that separates whole numbers from natural numbers. An integer can be positive or negative, so a positive integer, like +7, would not be the best representation of an integer. You'd want to represent it with a negative one. A natural number, just a regular counting number. I use the simple one 4 because it's a number that we use a lot. An irrational number would be radical 3. On the test, I don't think I had mentioned this, but when you had radical 1.1, you don't necessarily have to change it, but you have to kind of estimate, well, what is it going to be to put them in order, okay? Calculator would be very helpful with that. I guess I would have allowed that on the test. It didn't cross my mind at the time to mention that. Anyways, an irrational number is sort of a code name for a fraction or a decimal, okay? Even though whole numbers like 4 and -7 and 0 are rational numbers, okay? I hope that helps. Let's see, order of operations. Oh, sorry, I want to do this. Expressions from words. A lot of you messed up on this. So let me just kind of go over one problem here. 6 times the result of 4 minus 2. Okay. Now, the mistake that people make is they just read this in order and they say, okay, 6 times 4 minus 2. Now, if you did the answer like that, you probably got half credit on the test, okay, on that question, because that's incorrect. The word result implies that 4 and 2 have to happen first, okay? So you should write it like this. 4 minus 2 in parentheses times 6. Okay, that's how you should write it. Now, if the answer said to write it in simplest terms, then you can also go 4 minus 2 is 2, and then 2 times 6 is 12. Okay, you could do that, but if it doesn't say that, then this is how it should be written. This one is how it should not be written. Okay, and let me just say why. If I simplified this, I would get 12. If I simplified this, I go 6 times 4 is 24, minus 2 would be 22. So I'm going to get the wrong answer. Okay, that's why some of you got half credit on that particular, or on questions similar to that. Now with order of operations, remember, the order is parentheses first, powers second, times and divide as one category from left to right, and then add and subtract as one category from left to right. Okay, so in this problem, I just wrote a problem here. I didn't make it specifically like the exact same one in the test, but let me just kind of go over how to do this problem here. Okay, let me just try to make it easier for you to see. So the first step is parentheses. There's no parentheses or any other brackets or grouping symbols. So then we skip that step. The second step is powers, and that means exponents. And again, some of you might have got it wrong because you knew order of operations, but you messed up with exponents. So first, let's go ahead and change these numbers. Okay, so 3 squared means 3 times 3, which is 9. 4 squared means 4 times 4, which is 16. Okay, now I'm going to go ahead and rewrite everything else. So now, parentheses are done, powers are done. The next one is multiplication and division. I see multiplication and I don't see any division. So the next step would be to go 14 times 2. 14 times 2 is 28. Now I'm going to go ahead and rewrite everything else. Okay, now I'm color coding it just to show you what I've done and what I haven't done. So now the blue represents the steps that are already done. The red represents steps that I am just carrying down because I haven't done yet. So the next step is addition and subtraction from left to right. Now, that doesn't mean do addition first and subtraction second. It means addition and subtraction are one category. So for example, if this was subtract here, I would still do that first because it's left and to right. So 7 plus 28 is 35. 35 plus 9 is 44. Hold on a second, my paper's just going right off of the edge here. 44. And then 44 minus 16. Let's see. I'll just do it the natural way. I was trying to like do it in my head, but I'm on video. There's always that little bit of nerves when you're on video. Cross out 4, make it 3, put a 1. Okay. That would be 8, 2. Okay, so the answer would be 28. All right, I hope that helps. Now, just so that we're clear, I added this on to lesson 2.1, so I'm gonna jump to 2.1 right now so that we can actually do that lesson together. Okay. Let's see. Okay, now I'm sharing the screen again on the next lesson. Let's go over lesson 2.1. Okay, so to do one-step equations, that's what the lesson is on, means to find the solution of an equation, there are certain steps that must be followed, okay? Now, I want to remind you from the last lessons that an equation is a number sentence that contains an equal sign. Okay, I have several equations right here. 4 plus x is equal to 16. And I'll read the other ones later when we're getting ready to do them. But the steps of doing an equation can go by the term IOB. Now, I know that's not like a normal thing to say. Hey, this is my little brother, IOB. Okay, but IOB stands for isolate, opposite, and both. Now, I want you to memorize that. IOB, isolate, opposite, both. Again, isolate, opposite, both. Those are the 3 steps to solving any equation that's a one-step equation. Now let's go over what those mean. Isolate the variable. That means you want to make the variable be by itself, okay? That means no other symbols or no other numbers next to it. Isolate the variable by opposite operations. Just sort of a boom. I think someone's doing fireworks. I don't know if you heard that. Anyways, by opposite operations to both sides of the equal sign. Now I drew a picture of a scale here. I just want to show you. The scale is an analogy of an equation, okay? On a scale, whatever that's on the left side of the scale, in order for the scale to be equal or to be, balanced, then it has to be the same that's on what's on the right side, the same weight, okay? Now, I put 4x or 4 plus x on the left side of my scale and 16 on the right side of my scale. If those numbers are equal, then they should fit in there. Now, scales like this were invented, so for example, they would put a certain number of coins or gold or silver on one side, and then whatever it is that you're buying, maybe it's green or maybe it's fruit, they would put in the other side. When the scale is balanced, then that's when, that's the amount of money that you pay, okay? Kind of a simple way of like coming up with value, okay? But, so they literally based it on weight. But for our purposes, the scale is just to show you that whatever's on the left side and the right side are equal, even if they look different. I think this scale, I drew it a little bit, this side's a little bit lower, I apologize. I was trying to draw it like perfect, but just kind of ended up that way. Sorry about that. But the scale just sort of shows you. So the equal sign is sort of your best friend. That's what's going to give you the ability to answer the question. Because to find out what x is, I have to look at 4 plus something is going to equal 16. Now, this is a fairly simple problem, which you probably will be able to do in your head. But I want to follow the steps so that you can see how to do this. First step, isolate. I want to make x be by itself. Okay, so I'm going to go ahead and put a box around x to show that that's what I'm making be by itself. Opposite. I want to do the opposite operation. So we can clearly see that x is being added to 4, which I could say the opposite is true. 4 is being added to x. Okay, so in a case like that, in order to get rid of the 4, to make it be by itself, I do the opposite operation. Okay, so what I'm going to do is instead of adding 4, I'm going to subtract 4. Okay, I'll just write that as positive 4 minus 4 equals 0. Okay, so now that I've done that, I have canceled the addition of 4, and now x is by itself. Now, I must do the opposite operation to both sides of the equal sign. Okay, so for example, I subtracted 4 from the left side of my equal sign. I must subtract 4 from the right side of my equal sign. Okay, so now I have 16 minus 4, which is 12. Now I'm going to rewrite my equal sign, just bring it down, and then I'm going to rewrite my x because that's the only thing that's left. The plus was canceled essentially by the minus, and since I added 4 here, I subtracted it later. Okay, so now I have the answer x equals 12. Okay, now let's do the same thing, the same steps with the next problem. Isolate opposite both. I want to isolate the x, make it be by itself. Opposite operation, that's how I do it. What do I mean by opposite? Well, 4 has been taken away from x, so in order to do the opposite operation, I must add 4 back. Now, by adding 4 back, I think there's a property or something that you learned about that. The inverse property, I think it was called, but either way, it's the idea of that a number plus its opposite equals 0. So -4 plus 4 equals 0. If I take 4 away, put 4 back, I have 0. So now, for the next step, you could say I have x minus 0. So isolate opposite both. I must add to both sides of my equation. Now, a lot of people mess up here because they think of this type of equation, they think, oh, this said subtract, so I add, and then they get over here and they accidentally subtract because they're thinking of like the first type. So make sure that whatever you do is your opposite operation on the left side, you do the same operation on the right side. So 16 plus 4 is 20. So now I rewrite my equal sign. So x minus 0 equals 20. So I can write it as this answer, x equals 20. I wrote 10, I apologize. There's your answer, x equals 20. Okay? Now, let's go down to the multiplication and division problems. So I have 4x equals 16. Isolate. I want to isolate the x. Opposite. What is the opposite of multiplying by 4? It would be dividing by 4. Okay. So when I divide by 4, it's kind of like a fraction where both of these numbers can cancel to 1, and I have 1x left. When I write 1x, I just write it as the letter x. I'm saying that because a lot of people say, oh, well, like the addition problem, once I cancel that by opposite operation, this turns to 0. It doesn't turn to 0, but it just kind of becomes invisible, okay? And when we do the opposite operation, we do it to both sides. Okay, so 16 divided by 4 is 4. So the answer is x equals 4. Okay, now, moving on, I have a division problem. X divided by 4 equals 16. Isolate the x by opposite operation. The opposite of dividing by 4 is multiplying by 4. Now in algebra, the easiest way to write multiplying by 4 is to draw a big 4 on the outside of the fraction with parentheses around it. Now, the 4's cancel out, leaving you with 1x. Don't write it as 1x, just go ahead and write it as x. Now we do it to both sides. So 16 times 4 equals 64. I know you're like, wow, how did you do that so fast in your head? I'm a math teacher, so a lot of like some numbers you just learn them and you just kind of remember them. Like that's just one I happen to remember, even though most people don't really know their 16 times tables. Okay, what about equations with fractions? Let me help you with that. So let's say I have an equation like this. 2/3 x is equal to 15. Okay, 2/3 x is equal to 15. To solve this problem, I still do the same steps. Isolate. Isolate the variable x. Sorry, just moving around a little bit. By opposite operation. What is the opposite of multiplying by 2/3? it is dividing by 2/3. Now, the temptation is to write it like this and then just cancel them out. Now, that works, and of course, it would leave me with x. But to be more accurate, when I'm dividing by um, when I'm dividing a fraction by another fraction, you usually would write it like this, and you use the reciprocal of the second fraction. In other words, take this one, you flip it over, and it becomes 3/2. You also flip over your division sign, not literally flip it over, but you just turn it to multiplication. Now, when I do this by reciprocal, then what it does is it makes it easier for me to do the problem. 2 times 3 is 6. 3 times 2 is 6. I get 6/6, which equals 1. So then that would be 1x. Okay? Now, why am I going through this long step? Because I just want you to know that if you do this by reciprocal, then when you get to the last step, both, then you do this by reciprocal as well. 15 times 3/2. Okay, so 15 times, I can write it like this, 15/1. 15 times 3 is 45. 1 times 2 is 2. So my answer is x is equal to 45/2. Okay. Now I could simplify that more and do the 45 divided by 2, but I'm not going to. This is a sufficient answer. You're going to find too that algebra teachers are more concerned that you know how to do the algebra than that your answer is always in simplest form. Okay? So the point is, with equations with fractions, you still do the same steps. Isolate the variable by opposite operation, in which case on the left side here just means canceling, but do it to both sides. So when I divide 15, the whole number, by 3/2, when I divide by 2/3, it's easier to do it by multiplying the reciprocal 3/2, or flipping 2/3 over to 3/2, and then changing divide to multiply. Okay, it gives you the same answer, it's just an easier way of doing it. Okay? One last thing I want to go over. By the way, there's similar problems in all the examples in the book in chapter 2.1. So if you read all of the examples and practice them, and of course practice on IXL as well, then you should be able to get this. What about equations with negative integers? Okay, so let me just give you an example equation. We'll go x plus 7 is equal to negative 42. Okay, let's follow the steps. And the answer is, with negative integers, you still follow the steps the same way. Isolate the variable by opposite operation. 7's been added, so I subtract 7 to both sides of the equation. Subtract 7 from 42. Okay. Now, here's where it can get a little confusing. If you forget how to work with negative integers, remember the rules of integers. Okay. If the signs are if the signs are the same, you do what the operation says. If the signs are different, you do the opposite operation. Now, let's take a look. I have negative 42 minus positive 7. Now, that's where it can get a little confusing, because it's not written here as positive 7. It's written here as plus 7. And plus and positive look the same. Okay? So to avoid confusion, just remember, I'm not subtracting a negative 7, because then it would say minus negative 7. So this is a subtraction problem, but what is the opposite of subtracting? Because it says if the signs are different, do the opposite operation. That would be adding. So 42 plus 7 is 49. Now my original number was negative, so my answer is negative. So x is equal to negative 49. Okay. Now, again, you may want to go back to my video where I taught you the rules of integers for addition and subtraction. Those ones are a lot more tricky. The rules for multiplication and division are simpler, and I'll just restate the rule for multiplication and division. The rule is if I'm just went brain dead for a second. Oh yes, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. Okay, so just remember that if you're multiplying or dividing, then that's how you would get your answer. Another thing I just want to say, I'm not going to think of a problem, I'm just going to come down to the last step. Let's say in the last step of the problem you have negative x is equal to 4. Okay, and you're like, okay, well that's the answer because I isolate it and I have negative x. No, you're not done. Because negative x literally means negative 1 times x. The thing is we don't write the 1, okay? So in this case, I still must isolate by opposite operation, divided by negative 1. Both sides divided by negative 1. Now, when I divide by negative 1, if you remember, there's a property about negative 1, and basically it just changes the sign of whatever it's dividing, okay, or multiplying. So 4 divided by negative 1 becomes negative 4. Okay, hope that helps, and enjoy the lesson. Thank you.